All right, so we're looking at the picture on page 323 now. Sorry about that. We're looking at the picture on page 323. We currently have a minimum at 1, 10. We have a maximum. You kind of have to approximate that at 2 1/4, 13 about. We have another minimum at 4 1/4, 0. Then you have to pick one number to the left of all of that, so it has to have an x value below 1. And we have to pick one number or 1 point to a right of all that, so it has to have an x value more than 4 1/4. Put that into your list 1, list 2 in your calculator. We have 5 points, so we are running the quartic regress. And when I run the quartic regress, there's an IC there. Quartic regress. I get a bunch of decimals, so let's round. Let's go 2 places after the decimal. It is x to the 4th power, so it is basically 1 x to the 4th and negative 9.9 minus 9.9 x to the 3rd and 31.7 x squared and negative 37.7 x and positive 25. All right, this is a 4th degree polynomial. Okay, now if we were to do the factored form, we know that this is a 4th degree polynomial, which means there should be 4 factors. But if we look at the picture, it only touches the x-axis once. So, we can't just look at the picture and come up with the 4 factors. We do know that one of the factors is 4 1/4, or one of the x-intercepts is 4 1/4, so x minus 4 1/4 is a factor. As a matter of fact, it touches it once there with a nice U-shaped, so that actually occurs twice. So in theory, if I divide this into the 4th degree polynomial I just got, I should get a remainder of 0, but we'll see how ugly that gets. So if I want 1 x to the 4th, I'm going to have x to the 3rd. Multiply x to the 3rd times x is x to the 4th. X to the 3rd times a negative 4 1/4 is negative 4 1/4 to the 3rd. Subtract. Double check your negatives. Negative 9.9 minus a negative 4 1/4 is a negative 5.65 x to the 3rd power. Bring everything else down, or they're being subtracted by 0. 31.7 minus 0. Negative 37.7 minus 0. 25 minus 0. All right, I have x. I want a negative 5.65 x to the 3rd, so I'm going to put a negative 5.65 x to the 2nd. Multiply 1 times a negative 5.65. X squared x is x to the 3rd. Negative 5.65 times a negative 4 1/4 is basically 24 x squared. Multiply, draw your line, subtract. 31.7 minus 24 is 7.7 x squared minus 37.7x plus 25. I want to get 7.7x squared from x, so I'm going to need a positive 7.7x. Multiply 7.7x squared Negative 4 1/4 times 7.7 is negative 32.7, we'll call it. Whoops, where am I going? There we go. Draw our line and subtract. Negative 37.7 minus a negative 32.7 is a negative 5x plus 25. X, I want to get negative 5x. That will be negative 5 up there. Negative 5 times x is a negative 5x. Negative 5 times a negative 4 1/4 is not quite good enough, but a positive 21 1/4. Technically, it should work out to a remainder of 0. Our problem, of course, is rounding. All right, so I divided the x minus 4 1/4 into the original once. I'm dividing it again because that factor occurs twice, a multiplicity of 2. So this will be x squared multiply x to the third minus 4 1/4 x squared. Draw your line, subtract. I get a negative 1.4. I need a negative 1.4x up there. Multiply, gives me that negative 1.4x squared there. Multiply negative 1.4 times a negative 4 1/4, 5.95. I'm going to call it 6. Subtract. I'll need 1.7. Multiply. Let's see how bad it is. 1.7 times a negative 4 1/4. Whoops, that's not very good. Negative 7. Oh well. Again, that should come out to 0, but with the rounding, it doesn't. So what we're saying here is that the original equation, the fourth degree, models that graph pretty well. You put it in, you graph it on the calculator, you should get the same picture as on page 323. And the factored form would be x minus 4 1/4 times x minus 4 1/4, because that occurs twice, times x squared minus 1.4x plus 1.7. Now I could do the quadratic formula to that quadratic there to try to find my other two x-intercepts. But as you can tell by the picture, it doesn't touch the x-axis in two other spots. So what we got going on there is some imaginary numbers. So we will have 4 factors, 1, 2, 3, 4. We will be able to split this into 2 other factors, but it will require imaginary numbers, which we haven't gotten to yet. That's in lesson 2. I was going to wear that t-shirt today, but I decided it was Halloween and I shouldn't. Remember the t-shirt that says, it has pi and I, and one says be rational, and one says get real? It's because I is an imaginary number. So